So now I'm going to show you some two-step equations, and every time I show you something, I'm going to talk about the rules, okay? So here's one, 2x minus 7 equals. So when I'm looking at this, I ask myself, what is keeping the x from being by itself? And the answer to that is a negative 7 and a times 2. If I want to start my problem by dividing by 2, to undo that times 2, I have to divide this by 2, this by 2, and this by 2. That does not help me. It follows the rules. What I do to one side, I do to the other, but it doesn't help me solve the problem. So let's use that rule where I talked about doing PEMDAS backwards. And so that would mean I want to get rid of that negative 7 by adding 7 first. And I can't add 7 to a 2x. I can only add it to the numbers. So that's all I do. I bring down the 2x. This cancels, equals 8. Now, this is a step you almost always end with. A number in front of x equals another number. And because a number in front of x is multiplication, to undo it, we need to divide. This cancels to 1, x equals 4. Okay? And if you did 2 times 4, you get 8 minus 7 is 1. I know I have the correct answer. Let's look at another one. Now, this is what I was talking about by the fact that the rules are not going to apply. I mean, the rules, what you do to one side, you do the other, stuff like that, you have to do every time. But some of the suggestions, like use PEMDAS backwards, won't work every single case. So you saw in the last one, by us taking care of that positive and negative number first and then dividing, it helped our problem. But right now, I can't really just subtract this 2. It's in a weird spot. So this is called clear the fractions. Clear the fractions. And so when you see a problem like this, what you would want to do is get rid of this divided by 4 first. Because the whole side is over 4, we can multiply the whole side by 4, and this cancels to 1. And if I do it to one side, I do it to the other. So what isn't canceled is 2 plus x equals 3 times 4 is 12. And now the only thing keeping the x from being by itself is a positive 2. So I subtract 2. This cancels. X equals 10. And if I did 2 plus 10, I'd get 12. Divided by 4 is 3, so I know I'm correct. Okay, so this is kind of a random one. When you see one look like this, open your notes and go, what did she do? Oh, she multiplied by that bottom number and cleared that fraction so that you don't have fractions through the rest of your problem. All right, I want to look at one more. And then you're going to have to just practice these, guys. I know it's not, you might not feel that confident about it, but you're only going to get better if you practice. So practice, practice, practice. Try it. Okay, so here's another one. So PEMDAS backwards, we're going to subtract that 3. Now I see a negative 2, but that negative 2 is being multiplied to the x. So don't get confused and try to add it. Doesn't need to be added. It's being multiplied, so we're going to need to divide it, but let's not do that first. Let's follow that PEMDAS backwards rule and subtract 3 first. So we're going to bring this down. We have negative 2x. 3 and negative 3 cancel. That's the whole point. Unravel that side. Equals, now this is the problem I'm actually doing right now. 7 minus 3 is 4. Now, we're going to divide both sides by a negative 2. This gives me positive 1x equals negative 2. Positive divided by a negative is a negative. Now, I want to show you something. Let's pretend. Let's just pretend that on the last step we had, now don't write this because I don't want it to confuse your notes, or if you do write it kind of separate, because this is the answer to this problem. I don't want you to look back at this example and think what I'm writing in red is the answer. So maybe write it separate. let's say you come down and at the bottom it says negative x equals negative 2 or 2 or whatever it is. We don't want a negative x, but you have something you could do. Now, for my people who are getting this and math comes kind of easy to you, technically what I'm about to do is multiplying by negative 1. But I'm going to give everybody else kind of just a quick fix. At any point in the entire problem, if you want to, you can change all the signs. But if you change one sign, you better change all of the signs. And I don't just mean make them positive. I mean, if they are positive, make them negative. If they're negative, make them positive. So you are allowed to just change the signs, and what you do to one side, you do to the other. And now you have an answer that's reached your goal, because we don't want to say negative x equals something. We want to say x equals something. So that's something you can do if it helps you. Okay. I want to show you a little bit about perimeter. And I know both my 6th and 7th graders are watching this. So some of my 7th graders, you've kind of gone past this. So if you're like, I already get this, it's okay, hang in there, watch it, it'll be good review. My 6th graders, you got to kind of get used to this, knowing that you're going to do it this year, next year, and in 8th grade, okay? So basically, sometimes they're going to tell us, here's a square, and they're going to say, you know what, the sides of the square are S and S. Now, because they're both S, they have to be the same number. And they're going to tell us that the perimeter is, in this case, what was it? 132. And we got to figure out what S is. Well, I don't want to just plug in numbers all day until I figure it out. I want to make an equation and solve it. So what I know about perimeter is if I add all these sides, S plus S plus S plus S, that is how I get perimeter. Well, I also know that combining like terms, 1, 2, 3, 4S equals 132. And now I'm at that place where I get to divide both sides by 4. So really quickly, you know I'm slow, 3, 1, 2. Okay, so S equals, oops, not 34, 33. 33. Okay, so I took what all the sides were, I added them up, I combined like terms because they're all on the same side, and then I used opposites, and what I did to one side, I did to the other, and now I know what my S is. Okay, so let me show you another one where we kind of use that same math. Just bear with my horrible drawings here. So here's one. That one's not too bad. And they ask us to write an expression for perimeter. Well, I know if that side's 3x plus 1, so is this side. And I know if this side is 6, so is this side. So I'm going to write an expression where I write all of this together, this plus, 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 and then I combine like terms. So I'm going to write 3x plus 1 plus 6 plus 3x plus 1 plus 6. And then I combine my like terms. 3x and 3x is 6x. I like to cross them out sometimes so I don't forget what I worked with. 1 plus 6 is 7. 1 plus 6 is 7. 7 plus 7 is 14. This is an expression for perimeter. And if they told us the perimeter, I could solve it and figure out exactly what x means. Okay? So when you're writing an expression for perimeter, you're adding all the sides up. And then combining like terms, because they're all just together. They're not on two different sides of an equal sign. And if they tell you perimeter, you set it equal to that, and now you solve for x using all those things we talked about. Subtract 14, divide by 6. Okay, so hopefully that's helping. Please remember, the week we come back from break, if you're feeling really stuck, I would love to make some small groups and kind of meet with some people one-on-one if it's a quick question, but you need to communicate to me if you're feeling stuck. Okay, thanks guys.